They said they're nodding. Okay, good. Anyway, it's all. I've always wanted to come to the area, and I've enjoyed the visit so far, and I look forward to visiting UNC and North Carolina State tomorrow in person. So I'm going to tell you about a relatively new project that we have, CourseRank. So unlike other talks that you probably hear here where you have a lot of results, I don't have that many results. I'm going to take advantage of this opportunity to get ideas from you as to what are the challenges, what are some of the things that we should do with this system that we've implemented. So how did I get started on this? Well, literally a year and a summer ago, I was sitting around with some of my graduate students pointing out that there was a lot of activity in social networking around the world. Places like Facebook, which collect information on students and people, places like Flickr that collect information on photographs, Delicious that have bookmarks on web pages and so on. They're all hugely popular, and we thought that as information management specialists in our group, we should be addressing questions in those sites. I mean, what makes a site popular? How do people interact? How do people find things in these sites? We thought there were a lot of interesting questions, but we realized that it was going to be very hard to do research in these topics without having a site that we could experiment with. Yes, Netflix released a tape with rankings of movies, for example, and that's been very helpful if you're doing rankings, but it doesn't allow you to think out of the box. I mean, what happens if instead of ranking movies with 4 stars, we gave 10 stars, or we asked people for their 10 favorite movies instead of giving us a number? I mean, what were the implications? We couldn't check those things out unless we control the system. So we started looking around what would be a good system to build from scratch. We didn't want to compete head-on with Facebook or Flickr because it's very hard to attract users. So we picked a sort of niche where we felt that we could attract students, and that is a site to help Stanford students initially, but of course we think this can be generalized to Duke or UNC or other students, but anyway, to help students evaluate, rank courses, and also plan their academic career. So we looked around. We found that 3 of our undergraduates at Stanford had done a smaller project as an independent project. So I immediately signed them up to work with us. We joined forces, and these 3 students, whose names I guess I should show here at the beginning, Benjamin, Philip, and Henry Liu, have been the driving force. They've been the key implementers for what I'm going to show you. So what I'm going to do is 2 parts. First, I'll give you a sort of whirlwind tour of the site so you can see what has been built in 1 year. And then I'll talk a little bit about sort of the research challenges. We have done research on one topic, and I'll describe that briefly, but I think there's a lot of other things that we can do, and I'm looking for ideas. So this is the front page. If you go to the site, you probably can't read this, but it looks fairly similar to a lot of sort of book review sites and so on, in that you can look for courses. We have various tools to help you find the course. And then once you find the course, you get the description, when it's offered this year, the comments from the students. And one interesting thing here is that we're, in addition to getting our own data from the students directly, the registrar at Stanford has been extremely helpful and forward-looking and has been giving us official data. So for example, that distribution of grades that you get there is the official grade distribution provided by the registrar, but only right now for engineering classes. For other schools, we haven't convinced the deans to release the information. They're a little sensitive. They worry. Although we have self-reported grades because the students tell us what classes they've taken and what grades they've gotten. So we're pretty close to the official distribution anyway, and we're using that argument to get additional information. So you notice already that there are some buttons here to add. I'll talk about the planning aspect, so you can not just look for courses, but you can do your schedule and build up the courses that you're interested in. Okay, so that's one thing. Then if you look at the details tab, you can select different groupings. You can look at offerings, in this case, of all the autumn offerings of this course, or you can look at specific years when it was offered, and you can get a whole bunch of different data, both from the site and from the university. Like, for example, the workload is taken from the official course evaluations that Stanford does, and we get that information from the registrar and we present it. Here this is the expected grades the students self-reported when they did the course evaluations, and there's a whole bunch of other information you can get in the Details tab. There's also up there, I don't have slides for them, but there's a new Books tab, so you can see what are the textbooks for the course. Incidentally, this was a challenge, getting the list of books that are recommended for each class. You would think that our bookstore was, don't publicize this, our bookstore should have been happy to give us the information, but they view this as proprietary data. They didn't want to give it to us. So we've had to have a system where the students can report what are the textbooks. So we have the data, but gotten mainly from other students or from our own students going to the bookstore and writing down the names of the books for the courses. So what else do we have there? We have a ask a question and answer forum that we've also implemented. And another feature, students, that I don't have a slide for, is really interesting. When students say they're going to take a class, unless they say they don't give us permission, we can display to other students who's going to take this class. And apparently, the undergraduates love this feature because they're thinking between taking class A or class B. So they want to see, well, who signed up for class A and who signed up for class B. And if this cute girl or this handsome guy, whoever you were looking for, is enrolled, then they'll enroll in that class. So that's a new feature that seems to be getting a lot of traction these days, showing you who's signed up for a class. So you can see it's a lot more than just give stars to courses and so on. So another feature that we have is this course planning. So you can lay out the courses that you've taken. As I said, students will self-report, excuse me, I don't forget this, self-report what classes they've taken and their grades, and also classes that they're planning to take and what quarter. These don't have a grade because they haven't taken the class yet. So they build up their schedule, and incidentally, the fact that we compute their GPA here by quarter and overall somewhere else is an incentive to the students to report accurate grades, because they're very interested in tracking their GPA, and they're using this tool to track their GPA. It's been so successful that the course advisors, the departmental advisors, came to us and said, can you print this? Because the students are coming to us saying we did our planning in CourseRank and we want to show the advisor this. So we added a PDF button there that you can generate a PDF with the course plan. Little things like that, but that make the site very usable, not just by the students, but by the advisors that are helping them out. It also starts checking some of the requirements that at Stanford you have to take some general GERs, general education requirements, and the system knows which courses count for what, so it can tell you how you're doing in terms of matching those requirements. You also have a calendar where you can show on a week when your classes are being held, so you can plan what classes to take. Again, I'm not showing that in a slide. So we wanted to go beyond just this general educational requirements and said, well, why not capture the requirements for your major? Now, I'm sure you all know how complicated the requirements for a typical major at a university are. And surprisingly, there's various commercial products that have tried to tackle this. And it's a really, really hard problem because the constraints are so complex. There are things like, well, yes, you have to take 2 out of this list of courses, but there are exceptions. This pair doesn't count. And if you take this one, you have to do something else. And courses, if you use this course to satisfy this requirement, you may or may not be able to use it to satisfy some other requirement. So another thing that we've been doing is trying to capture what are the requirements to graduate in such a way that the administrators of the departments can enter that information into the system. This is work in progress. Our first version we thought was really cool and neat, so we went to talk to a few department managers, and they couldn't understand a thing of our interface. They just were stumped, so we had to go back and redesign the interface so they could express the constraints for the courses. We've at least manually ourselves captured the rules for 5 departments, the most popular departments, plus computer science. And now the students, I really like this feature. It's not my idea. The students came up with this progress bar that you see here. So you can see how far into your degree you have gone. If you open that, for example, the math department, math requirement is incomplete. If you look down, you satisfy probability, the discrete structures, but you're missing this calculus course. Okay, so now the students can sort of see what they're missing. And if they click up here, this progress bar shows you how you've done with the courses you've taken, but you can tell it, well, what about the courses I've taken with the ones I'm planning to take? And you can see how much you've advanced. Okay. Now, another reason why I like this is because now when we get to recommendations, eventually, we're not doing this yet, we'll be able to include this in the recommendations we make. So if Carlo wants to take a biology class, for example, well, we might tell you there are some good biology classes that people in your major or people that have liked courses that you liked and so on have taken. But we might also point out that, well, in addition to this biology class, there's some other science class that is part of your requirements. So you might want to take that into account in the ranking, right? So it's not just popularity, but it's also what helps you complete your degree fastest. Now, what exactly does it mean to rank courses by how useful they are for your requirements is an open research question that we're just beginning to tackle. But I think there's a lot of interesting things to be done there in ranking things that have complex rules that describe their relationship and the ordering in which you take things. Okay, so that's our requirements part. So you can also get all sorts of statistics and recommendations. I'm going to talk more about recommendations, so I'll leave that for a little later. The important thing about this page is to show you how many students at Stanford are using the system. Now, you might think that 7,000 students is not a very large number of students compared to how many people use Facebook, of course. But Stanford is just a little bit larger than Duke, 14,000 students, 7,000 are undergraduate, and 7,000 are graduate. And most of our users are undergraduates because the system is tailored to undergraduates so far. We're trying to make it more attractive for graduate students. So the way I interpret this number is that we have basically 85, 90% of the Stanford undergraduates using the system on a regular basis after only 1 year of operation. So yes, it's not a huge system, but I think it's been quite successful. And it's going to provide this laboratory for our research, what we set out to do. Incidentally, the students have given us some feedback. In the Stanford Daily is our sort of local student paper. They've written a couple of editorials. You can read about this. Actually, it sort of created some, quote, problems for the registrar because now the students, it's not here on the slide, but if you read the editorials, they're saying, how can 3 Stanford undergraduates in 1 year build this very nice site for us while the university has spent millions on these commercially developed systems that are really awful? So that's the type of problem that we're generating for the administration. But thankfully, our registrar and administration has reacted positively. They come back to us and they tell me, Hector, we need more students like the ones you have here so we can work on the other systems, which is the right reaction, right? You don't want to close this down, but you want more students to help the administration develop nice system for the students. Okay, so what are we going to do? That's sort of the description of the site that we have so far. And as I said, there's several things that I like about the site that make it a little different than your standard Amazon book review site or whatever. First, as I already said, the data is rich in the sense that there's a lot of constraints and different types of objects. It's not just books that you can read in any order. There are rules as to how you take the courses. The courses are offered certain quarters, certain years. They're offered by different instructors. There's grades, there's reviews, there's ratings. There's a lot of data. So when you start looking at recommendations, there's a lot of challenging problems, I think. The collaboration with the university also is unique. I think that we're not just getting what the students give us, but we're integrating it with a lot of official information. So that also raises some interesting questions on data integration. How do you combine the data from different places? The fact that it's a closed system, that it's not open to the public, is also good because the students are much more willing to collaborate with us, give us good reviews. The reviews, we've compared the reviews that people write with the reviews that they write on the official course evaluation forms, and our reviews are much more useful to the students. They take more time. If you're going to, sometimes the students just do the official evaluations in a hurry. Here they are more thoughtful and are taking more time. We also have, thanks to the administration, user identities, so we know who is doing something. So we know if it's an instructor, if it's a student, if it's an administrator, so professors can add comments to their class, but they're flagged as this is the instructor for this class. So knowing the identities of people is also useful. Yes, a question, please.
The closed system seems to be a nice advantage with respect to the legal aspect, like for Are there things that you would have liked to do in the system that you weren't able to do because of, access to information, like knowing which other students are enrolled in class? I don't know what the legal aspect of that is, but are there things that you can't do?
So I don't know if people can hear the question. I'll try to repeat it. The question is, are there things that we can't do for privacy constraints and so on? Well, you see, the data that we have is mostly our own data that we collected. The data that for like which courses you're going to take is not the official information. It's what the students tell us that they're going to do, except for the grade distributions and the course evaluations, which the university has agreed to release to us. All the other data is generated at the site. And it's the student, if it doesn't want to disclose that information, he or she can either say don't disclose or just not come to our site. So far, we have not had anybody complaining. And I thought, for example, this feature that I said that we're going to tell the students who's planning to take a class, I was a little worried. But the nice thing about having your main implementers be undergraduates is that they told me, oh, no, we've talked to our friends and they all love this feature. It's going to be great. So I'm letting them guide the project, and if we run into problems, we'll shut it down. The feature that's giving us problems. Yeah. Actually, we have to be careful with the students when you add a course to your planner. We tell the students, remember, you have not enrolled in this class. Don't think that by putting it in your shopping cart or whatever you've enrolled. You still have to go to the official university site and enroll in the site. Although our registrar is forward-looking enough that he said we really should change this. We want to provide access to you so that from CourseRank you could call an API and register students and get their grades. That I'll believe it when I see it, but that's something that he would like to definitely see. Okay, so, and of course, well, I should stop. Are there other questions or comments? No, okay. So, and of course, the last bullet is that we have control over the site, so I think this opens the door to all sorts of interesting opportunities. I've talked about the academic requirements, checking, and recommendations based on those. I've talked about the rich data, and I'm going to say more about that here. The question-answer forums, it's also a lot of interesting questions. I mean, initially we had separate discussion forums, but if you think of it, the fact of your commenting and evaluating classes should really be integrated into one, because I might ask a question about a comment. It's not two separate activities. I'm commenting, I might ask a question about the comment. Some questions might go to the department administrator. What are the prerequisites for this class? Or can I take this other class instead of this one? So we really need to think, what is the flow of information in this type of system where you have professors, students, and department managers working together? We would like to have an integrated forum. We don't have that yet, but we'd like to have that. There are all sorts of social issues that could be addressed. I've talked to some of my social science colleagues at Stanford, and for example, one of them is very interested in using the system to see if there's racial bias when people evaluate. So we're thinking of displaying the professor's photograph while you're filling in a comment, and then by doing that selectively for some people, figure out if there's a bias when you see the picture of the professor versus no picture, for example. That's a problem that he's very interested in and would like to use our system for. Okay, so those are the challenges. When I gave this practice talk a couple of weeks ago before coming here, and one of my students says, you always tell us to give a related work slide, and you don't have one in your deck. So I added quickly my related work, that just to point out, yes, there's a lot of work that's done here. I'm not going to give you an overview of what's been done, but yes, there's obviously lots of work done on forums, on social issues, on recommendation systems, and I'm slowly learning about all that, but we're still going ahead with the project. So maybe at this point I should stop and see, do the people at the remote sites have any questions? Because now I'm going to focus on sort of the recommendation aspect, where I said we've done some preliminary work. But if there's any questions on the system in general from the remote side.
Can I ask a question from UNC? Do you hear me?
Yes, we hear you. Go ahead, please.
Yes, when I'm advising students, one of
That's a good question. So the question was, we're not providing enough sort of reports on the faculty. How is this professor rated, independent of what classes this professor has taught? We've had requests for this feature. You can find out who's teaching a class, so you can find out, but it's not the main sort of way to find out information. So we're thinking about adding that feature. It's definitely a useful feature. I'm a little worried about how my colleagues will react to that one, because now you're rating professors as opposed to just the classes, so it's a little bit more direct. But maybe we'll do it. But yeah, that's a good service that some people want. Okay, so now let me talk again. Oh, yes, please. Question. Yes.
Do you provide connections between classes?
Connections between classes in what sense?
Like a certain class prerequisite, or by nature they have some kind of by subjects they have some close connection.
We are doing that a little bit in the requirements for a major. That's part of the issue, that classes have to be taken in a certain order. So that's one of the many constraints that you have for graduating. Yes, so we are doing that. Although, as I said, it's still a challenge how to get the university personnel to actually tell us what the constraints are.
By searching, and also certain classes at the different departments, and have different names and in different contexts. And actually, by nature, by science, by theory, they are the same.
Yes.
Okay.
So that's another issue. I mean, some courses are cross-listed, but that we get from the registrar. So the official cross-listing, we are getting that, and that's available. Now, whether classes are related or not, then you have to use, I didn't show our searching features, but you can actually, this is a new that's just being released as we speak. When you search, say, for biology, or let me use history. So history. And I want a history course. Then in addition to getting a listing of the courses that have the word history in them, you get what's called a tag cloud, which is popular on the web, of terms that are related, and the ones that are more popular are bigger. So you type history, and then you can see American history, European history, art and history, and then that can help the student say, oh, art and history, I hadn't thought of that connection. So then you click on it, and now the query is history and art. The list of courses gets narrowed down, and you again get a tag cloud that's updated instantly that shows you what terms are sort of useful for browsing and pruning that list. So that might help you find courses that are related to other courses or that match your interests. Good question. Yes, please.
Yeah, I was wondering if you could talk a little bit more about how you draw this data out of your students. So on a site like Facebook, they want to publicize that they have this great taste in music or movies, or that they have these cool friends. So there's an obvious incentive for them to input the data, and it seems like you have, for certain classes of data, you provided very nice services for them to, again, draw it out, like their grades or course planner. I'm wondering if there is data that you would really like to be able to get them to input, but you haven't been able to design a service to draw it out of them yet.
So the question is, how are we having trouble getting the students to give us the data? We don't have that much experience. The data that we've wanted, we've been successful at getting. One of the tricks, again, the students by implementers decided this, when you first log into the system, you get taken to a page where you have to give us the courses you've taken, or list some of the courses you've taken. And of course, you can skip out of that, but that's the first thing you are faced with, and then people fill them out. I think the planner is great. Once people find out through their friends, word of mouth is the way these things spread, that this is the place to go to plan your classes, then they're incentivized to fill in all the classes and give us their grades. So I think that giving them a service that for the data has been the key so far. We haven't really yet tried other types of data that we might struggle getting. Okay, so recommendations. Unless, any other questions? No. Okay, so recommendations. So there's a lot of things to recommend. I mean, obviously you want to recommend courses, right? What class should I take? But there's a lot of other things that you could get recommendations for. For example, I've been at Stanford 2 years, and I still haven't declared a major. I don't know, here at Duke, when do you have to declare your major? Is it second year? But some students haven't declared in the third year, just like at Stanford, yes. So I've taken all these classes. I don't know what I should major in. Why don't I go to CourseRank and ask it, well, recommend a major? I mean, you know what courses I've taken. So look for other people and see what matches, what majors are good. Now, of course, you don't want to rely entirely on this, but maybe it'll give you some suggestion that you hadn't thought of. Oh, yes, I was thinking of computer science, but hey, EE is also close, and I've satisfied more of the requirements, so let me consider that. Or another one that my students came up with, you know, this calculus course, I have to take this calculus course, but I wonder what is a good quarter to take this class. Because is it easier or harder, or what is the right sequencing? So tell me, should I take it in the fall? We have a quarter system in the spring, or in the winter? What is a good quarter to take the class? So just like that, there are all sorts of things that one could recommend in the system. And you could base it on all sorts of other things. So when we started implementing the system, we said, well, we really want to experiment with a lot of different strategies for recommendations, not just the final objective, but the way we recommend. And we looked around and felt that most of the recommendation engines out there were hardwired, right? You write it in C or write some SQL queries or something. So we had this vision, and I'll tell you a little bit more as how we implement it, but this is just a vision, that somehow an administrator over here would define what we call workflow. So this is a strategy. I want to recommend courses based on what students that are similar to me by grades, for example. And I also want to recommend majors, and here are the parameters I'm going to take to recommend a major. So this is provided in a high-level way. I'll show you some examples how we describe this. And then the users, the students, would come in. They don't program these things. They, through an interface that, again, I'll describe later, the beginnings of this interface, will then get to choose whether they want a recommendation for a class or for a quarter or what, and might provide parameters like, I want a course that has the word biology in it, for example, and then the recommendation engine will run through the workflow and execute it. So that's sort of the vision. Now, what does this workflow look like? Well, I'll show you a more concrete example, but this is actually the way we started thinking of this is, well, there's sort of like a flow of information. So for example, I know I want something about me, and I want to compare myself against students to get similar students to me. So think this is, it's sort of like a query plan, right? But there's this new operator here that somehow gets a list of students that maybe have been filtered, some selection, projection in some way, and I get, this is the students that are similar to me. And then the students that are similar to me, somehow combine them with the courses to get the list of recommended courses. So that's the intuition. I'll show you this in a little bit more detail, what our version, this is sort of version 0, and I'll show you version 1 in a few minutes. But that's sort of the idea. Can we describe the flows? Now, there's nothing new in this. I mean, you could, as I said, you could write it in C, you could write it in SQL queries, but we're trying to capture in a nice way a lot of types of recommendations. So that's what we're trying to achieve. Okay? So let me now walk through some of the things that we developed to do this very flexible type of recommendation. We call our engine Flex Rex for that reason. So I'm going to use examples from CourseRank. We have courses with the usual fields, the course ID, the department, students, SUID is the Stanford ID, and the history, which sort of tells you what courses you've taken and how you rated those courses and so on. It's pretty sort of obvious basic data. There's a lot of other tables that we have, but I'm just going to focus on those 3 for this talk. Okay? So here's, in case you're not familiar with recommendations, here's one of the many ways you can sort of compare things using something called Jaccard similarity. So suppose you have 3 students, Joe, Sally, and Fred, and they've taken the classes that are indicated in the history table. I've left out a lot of the attributes just for simplicity. And the 3 classes are art, computers, and biology. Okay? Now, how similar are Joe and Sally? Well, one way to do it is to say, well, have they taken the same courses? So what you do is you compare the courses that are taken by Joe and Sally. So Joe has taken 2 classes, 10 and 20. Sally has taken 10, 20, and 30. So there are 2 classes that they've shared out of a total of 3 classes that they took together. So then you say, well, the similarity of Joe and Sally is 2/3. And if you look at Joe and Fred, it's 1/3 in this case. So this is one type of comparison that you do. Of course, you could take into account the grades and the ratings and all sorts of other things. So what you end up with at the end is the students with a column added that gives you the similarity to Joe in this example, right? So that's what we're trying to do, get a flow of students that's going to get ranked, and we're going to add a column that we're going to call score that will then tell us how those students compare against using this metric. Okay, so that's sort of the basic comparison. And what we're trying to get to is some nice way, this what I call the recommend operator. Now, I'm not sure that's the right name, compare, recommend. We're still struggling with what is the right name. Maybe you can tell me. But for now, let's just call it the recommend. It's not quite the final recommendation, but we're calling it the recommend operator. So as I said, you want to get students, you want to get Joe in this case, and you want to get students similar to Joe. That's sort of the flow. And remember, this operator is going to take the left-hand side attribute, the students, and is going to score them and add a column. That's sort of the flow. The left-hand side is different than the right-hand side. The right-hand side, Joe, is what you're using to compare against or to rank, okay? So that's the flow. But when this was our vision, we realized that things aren't that simple, unfortunately. It's not just students and Joe. There's other data that you need to consider in doing that. And there's not just one operator. It takes a whole bunch of parameters like the Jaccard function or other functions that you're trying to use and other things. So the next couple of slides try to show you what our abstraction is. It's very straightforward, but it still took surprisingly long to end up with this abstraction for the model. So instead of having a variable number of parameters, I just didn't like that. I mean, it felt like you really have two things: the things you want to rank, like students, and the things you're ranking against. So we came up with this idea of a nested relation. Well, it's obviously an old idea, but we felt that it fit here very nicely, but nested only two levels. We didn't want a whole machinery of nested relations. We said, okay, if you're going to compare students against Joe, for each student, like Sally, we are going to embed in a table in one of the attributes here the things that we need for the comparison. Right? Of course, this has to be done with other operators down here. There's an embed operator that takes data from one relation and embeds other interesting things into the tuples so that the next steps are very clean. You don't have to say what information about Sally you're going to use. It's all now embedded in this table in a very nice way without further nesting. So it's limited, but we felt that is plenty for what we want to do. Similarly, for Joe, you can then have nested information, and now you only have two inputs to the recommend operator, which is what we wanted. So that was one simple idea. Come up with nested relations to deal with that. And then the tree now is beginning to look a lot like a database query plan, right? So you have the table students. You can do traditional things like select and project attributes. Then there's this extend operator that takes the students and stuffs in the courses that match on the matching attributes, and you create this extended nested table, and now that's fed to the recommend operator. And similarly for the other side, you can have same thing, right? So nothing deep, but it just seems to click in place. It's very nice, I think. Okay, so now the recommend operator. How do we describe what are the operations? There's a Jaccard function, but how do we generalize that? What happens with other functions? What are the parameters that you need? Well, it turns out, again, after a lot of thinking, you find something that's very simple, that you need two bits of information. One is what we call a compare function that compares two tuples, and then there is an aggregate function that combines scores. I'll tell you about the aggregate in a second. I'll start with the compare function. Here's one example of a compare function. In this case, I'm just doing the age difference, just a very simple one. It's not Jaccard, it's just an age difference. So what this recommend operator is going to do, it's going to take each tuple and it's going to compare it with Sue, age 19. So as you can see, Joe, the difference is 1, 1, and 3, and that's the score that you added at the end. Okay, so the compare function that you provide takes two tuples and compares them. And our system has a library of functions. Jaccard is one, difference, and so on. Now, of course, this is a simple, there's no nesting in this table. You can have, like Jaccard, that's the same thing. This is the compare operator, and it compares one tuple to one tuple. In this case, it does the Jaccard similarity of the courses attribute. How many courses are similar? So, for example, for Fred, Fred has 2 courses, and Sue, that we're comparing against, has 2 courses, and they overlap in 1 out of 3, so you get 1/3 as the score. Okay, any questions on this? So that's the compare part of the recommend operator. Now, if you notice, all my examples so far have only had, oh yes, please, go ahead, question.
Yeah, so this approach is somewhat guilt by association. Let me look at what my body does, and I will do something similar. And this is from NC State. And I have a question: if you expand your database with information from alumni, this effectively is the reason why we go through this rigorous studies, because we want to be successful in a particular career. So now you're asking the question: I want to be similar to the CEO and making $500,000 a year. Which paths I have to take? Which courses I have to take? So you basically do an inverse problem. You want to find the most optimal path that will get you to the career path of being a CEO, or being an academic professor, successful, or whatever.
Great. I love this thinking.
You've been thinking about this.
Not yet, but I love this. Yes, we should work on this. We need to capture more data, and then this is even more recommendations, right? Which is the course that will maximize my chances of becoming rich, for example. So yes, that could be done. We're not collecting that data, but hopefully the model I'm describing here will be able to handle that type of evaluation, right?
If you follow Bill Gates' example, you have to
That's right. That's true. So we might have to put a few stop rules there. Don't give this advice out. Good point. Anyway, let me continue, if there are no other questions, with the just with the framework to describe recommendations in general. So all my examples only had one record over here, but you often have multiple records that you want to compare against. So for example, now I'm going back to the difference comparison, but now I want to compare, say, Fred with not just one person, but this whole set of people. And the general idea here is that you're taking a tuple and you're going to compare you're going to apply the compare operator with each tuple, and then the aggregate function is going to aggregate all those values into one score. So for example, for Fred, I compare using the diff function with Sue, and that gives me 22 minus 19, a difference of 3 years. And then with Tom, it's a difference of 4 years. So the score is the average of 3 and 4 because we selected the average function. Okay, and surprisingly, those two parameters are enough to describe, we think, a lot of basic recommend operators. How are you comparing tuples, and then how do you aggregate the scores into one number? And again, we have a library of functions that cover a lot of cases. Whether we cover all the cases or not, I don't know. We're in the process of extending the things that we're trying out and seeing if we need more, or maybe we need a different type of operator, but this seems to be fairly powerful. So I'm sort of pleased with this, even though it's very simple, but just that has all the power. Okay. So now another thing we can do now with this machinery, so we have this will produce a list of recommended students. I've changed the function here, but now we have similar students, and now what we can do is we can compose these things. We can now get the similar students and feed them to the next recommend operator and get our final answer. So let me show you this identify comparison function is sort of interesting because what it does is it pulls out information. So I just added this slide to illustrate this, I think, sort of cute function. So here we have the courses that come on the left. So you want to rank the courses. And we have the students, and we've embedded the courses that they've taken. That comes out of the recommendation of the similar students. And we have the scores. This tells us how similar the students are to me, the person who's asking for the recommendation in this case. So what this operator does is it picks out for each class, for example, for the computer class, it compares this tuple to each of the tuples, and the comparison is basically extracts the score for B out of this tuple. So it says I got a 3, and the value is one of the similar students rates this class as a 3. The other student rates my class B as a 1. So now I have two scores, a 3 and a 1. Now I'm going to use the weighted function to average them. It's not just a simple average, but I'm going to weight them by the score, by the 1 and the 5. So therefore, the 3 gets a score of 1 because it came out of a tuple that's a student that's score 1, similar to me. and Sally, which is only half as similar to me, gave it a 1, so I weight that score by less, and the overall weighted average is 2.3. So that's how I get now my courses nicely ranked by how they were ranked by students that are similar to me. So again, it's the same thing, a tuple comparison function. In this case, it's just extracting the score, and the averaging function. Okay. I don't have time to talk about, we have other operators. Specifically, there's a blend operator that I think is very useful to combine scores. I mentioned earlier that we might want to combine a ranking based on how useful a course is for your requirements with a ranking of how popular they are or how well you might like them. And you want to combine those two. Or top K, which says I don't want all the rankings, just want the more efficient ones, or the ones that are above a threshold of value of score for me. So those are things that we plan to add. We've implemented all this, and this is a diagram, and it's basically the same as the vision that we had initially. The users down here, up here, select the workflow. The administrator designs the workflows, and they get executed. So let me illustrate. This might be only of interest to the database geeks here, but if you excuse me just for a couple of minutes, let me show them, because I think it's sort of interesting how we go from this plan to straight SQL queries that are then executed on a standard database. So basically, you have to convert this to a SQL plan. Obviously, some parts are very simple, like this is just a projection, and the extend is just doing a join. But the nice thing is that we don't have to actually materialize the extended relations. The extended tables was just a concept. When you get down to implementing it, the system will just issue standard SQL. We don't materialize those things. So I'm running a little low on time here, so maybe I'll just show Shivnath and June and anybody who's interested afterwards what the magic is, because I think this is kind of cute. So for example, the first part gets converted into this query, which again, only a database geek will appreciate. But the interesting things are, for example, we do create a temporary table here that is then fed to the other part, but there is no join is necessary in this case to produce the evaluation. In general, there is a join for the extended table, but it so happens that in this case it doesn't, and we sort of optimize for that. And the Euclidean function is sort of embedded into the select statement. So this is the computation that you have to do in this case to compute the Euclidean comparison of the tuples. So I find it kind of surprising that it all can be done just in SQL if you are good at generating SQL. So it's a little bit of a challenge. The other two queries the other operator actually requires 2 queries to generate. So again, here there are some interesting challenges as to what is the best mapping of our plan to standard SQL. Which tables should you materialize and which ones you should not? So there's some interesting optimization problems there that we are starting to address. Okay, so I'd rather spend the last 5 minutes on a little bit of the interface, because so far I've described the engine. These workflows are going to be designed by people like you and me, not by non-CS people. So what about the user? Well, the ultimate goal that we have is that we want to do general recommendations and sort of combine it with search, because when you're searching for courses, it's really the same task as looking for recommendations. You want to do something, and it's not just courses. You're searching for things in life. What do you think will be my grade in this class? For example, that could be a question you might ask the system. So how do we do that? And how does the poor student interact with this complexity? This is not implemented yet. We're starting to struggle with what is the interface. And I'm not a HCI person, so if we have HCI people here, I'll gladly take your advice. But this is our vision right now, that the student will somehow say, well, what do I want? So you first get a list of things that the student can tell you, that the system can tell you about. Are you looking for courses? Are you looking for a quarter? Are you looking for a grade that you're going to get in a class? Are you looking for a dollar amount that you want to make when you graduate, for example? What is it that you're searching for? And once you select, for example, course in my example, then you get 2 parts. One is what we are considering filtering conditions. So you say, well, are you interested in courses in a particular department or courses that have the keyword biology in them? So you sort of filter down that. But in addition, we give you a set of strategies that we know about. You want us to recommend based on students that have similar taste to you or students that have gotten similar grades. Now, this is written in English here, but each of these things translates to a workflow that we've designed in advance. So that's sort of the available workflows, although the student doesn't know anything about workflows. It's just strategies that you can select. And then once the student says, oh, okay, I want students, the recommendation based on students that have similar tastes to me, then you get additional filters that say, okay, so which students are similar to you? Students in your department or freshmen or seniors? What other conditions might you have in mind? Of course, if you don't have any, you can just leave those blank. So this is sort of the vision that you get to select the workflow via some nice interface that guides you to the ultimate choice. Okay? So that is what I want to say about the recommendation ideas. There's a lot of issues still to be resolved, as you can imagine. This is just the beginning. There are interface issues. Is this the right approach, what I just described? There are flex-rex questions. I mean, I claim that this is a very general model for any type of recommendation, but this claim still has to be substantiated with more experiments, more demonstrating that it works for more things. And then there are systems issues, optimization questions, as I mentioned earlier, performance issues. Just to show you that the system is running, I could give you a demo on the system, that would be one way, but we've also done some experiments, very preliminary, to see how this will scale as we vary, for example, the number of students in a relation. So this little experiment artificially cut down the number of students. We had about 5,000 when we did this experiment. We sort of cut it down to half and a quarter, and we saw how long it takes to do the recommendation of our running example, recommend courses based on students that are similar to me. So you can see there's a plan generation function, which incidentally is way too high. We think we can cut that down. And then, of course, yes, it does take more time, but it's not exponentially more. It's pretty manageable. Yes?
What exactly will plan gen and do? Because the workflow has already been defined. Now, plan gen is...
Yes, that's what I mean. Yes, we should have done that in advance. So this is doing all the work at runtime. Yeah, so it actually is taking the high-level description and figuring out what is the SQL that we need to run, and then giving it to the database system. And a lot of that overhead is just talking to the database system that's sort of a fixed cost. So as I said, this is very preliminary, and you should be objecting to this. Anyway, I just wanted to show that we've started to play around with the system, and here we've looked at the difference between the different comparison functions that are available that people are using. What is the impact? It seems that it's not too high in terms of how much time it's going to take to do the comparison. Again, remember, we're doing it for one student. We're a little concerned. We're not expecting the number of students to grow too much, but we are a little concerned that if we have all 7,000 students asking for recommendations at the same time, then are we going to be able to cope with that? That's the real danger. And incidentally, the workload here is very focused. At the beginning of each quarter, we get a huge spike, and everybody wants to look at the system and get recommendations. So that's why performance is an issue. Okay, so I think I want to leave a few minutes for questions, but that's basically the end of the presentation. I told you about this system, CourseRank, that is being used by Stanford students to not just find out about classes, but do their whole academic planning. And we're trying to link it with other resources like the bookstore that I mentioned earlier, books, course syllabi, and so on. And we'd love to see if other universities might be interested in using this system. We think it's flexible enough that it could be used by other universities. And then I described FlexRex, which is this model for describing recommendations and then translating them into traditional database commands that can be executed by any old database system. And if you want additional information, we do have a paper on FlexRex that you can find by searching FlexRex and Stanford. Unfortunately, FlexRex there's a product somewhere that's not ours, so you have to put FlexRex and Stanford to find us. And if you want to see the system, you cannot log in and use it because it's only for Stanford people, but the students have put a nice demo there that you can see, a video that walks you through all the features more than what I've shown here, and even testimonials. They've gone out and interviewed students saying how good the system is, which I think is a little unnecessary, but they've done it and it's available in case you don't believe me and you want to hear Stanford students telling you. Anyway, that's the end of the presentation. If you have any questions or comments.
Remote
Yes. Oh, yes, I should ask the remote people first, I was told. Yes. Go ahead. Yes, we're hearing you. Go ahead. How do we know if? Sorry, now you faded away. Can you speak louder?
How do you know if students are benefiting from the recommendations? Do you have any data on that? Because often I find recommendations are reasonable, but not really insightful.
Yes.
And, do you have any plans on using an argumentation-based approach versus just comments or nested comments? You know, when users give comments, could they specify that, you know, I undercut this argument, this other comment that somebody else has made, or I support this comment. So have more structure to the comments.
Yes, these are all very interesting questions. We've started to think about the question. One of the questions is, well, how do you know if you're giving out good recommendations? So far we're exploring two options. One is to bring in some students and do a user study, a live user study, and tell them, here are the recommendations, and have them tell us explicitly if they think this is a good course for them or not, right? Without taking the class. So it's limited in that they're just deciding based on the current information that they have, whether our recommendations were good. The next level, or a different approach, is to track on the system which are the courses we recommend, and then notice if they put one of those courses in their, I like to call it the shopping cart, but it's not really a shopping cart, in their planner as a course they're going to plan to take. That is a sign that they found something in our list useful enough to seriously think about putting in the planner. So we could try to track the correlation between what we recommend and what the students are doing. Another nice thing about having a live system, that we can do this type of thing. Of course, the ultimate test, which I don't know how we're ever going to do, is to track what we recommend with after they take the class. Well, I guess even after they take the class, we could see how they rate the class. I guess we could still do that. But whether ultimately the class was of value to them, I mean, that I think is beyond what we could do, right? But anyway, there's a lot of interesting questions as to how do you evaluate the recommendations and the advice you're giving the students. Are there other?
Another one.
Yes, please.
Yeah, one more over here, if you don't mind. I was wondering, from a social networking standpoint, how you can say that CourseRank itself isn't affecting this to a degree that any analysis that you want to do to so much a degree that it's unusable.
That the results of the analysis are not meaningful.
Well, that they're affected by the existence of CourseRank itself.
Well, yes, that is a problem. Yes, it could be that CourseRank is biasing the way people behave and so on. Yes, yeah, good point, but I don't know what to say about that. That could happen. Any other remote questions? Okay, do we have local questions? Yes, please in the back.
Do you have any comments about the software engineering problems related to such a project? For instance, in order to develop this system, probably you need to write code in 4 to 5 different programming languages. I mean, you need PHP, you need JavaScript, you need SQL, you need Ruby, you need, and especially when you try to add strategies, you want to be able to abstract, and you don't want to be looking at source codes on 4 different programming languages with 4 different semantics. And if you were to handle this to the registrar people or to another university with 160,000 students instead of 8,000 students, I mean, how do you see, maintaining such a system and being able to keep it alive?
Another excellent question. Unfortunately, I don't have the answer for that. I've been really lucky that these 3 undergraduates are amazing. I mean, my main contribution for the implementation is staying out of their way and letting them build it, because they talk to their friends, they know what the features to be added, and they're just really good at, they know SQL, they know PHP, they know Java, they know Adobe Flex for the graphics and so on. And so my advice, if you want to build a system like that, get some Duke undergraduates or some UNC undergraduates or some Stanford undergraduates, some really smart people, and let them do it. Yeah, it would be an interesting case study to see how to manage this. Our administration, the registrar, has actually funded a new position. They're so interested in the system that they're, of course, worried that the students are going to go away and what's going to happen to the system. So they have a full-time person now that is going to work with us. And when the students graduate next year, or in 2 years if they stay for a master's, then the registrar wants to take over the system and run it from their facilities. And we'll find out how good this code is. I mean, it works well, but we'll find out those issues you raise of maintainability and so on.
Whose intellectual property is it at this point?
Good question. The question is, whose intellectual property? At Stanford, and I assume at Duke it's the same thing, everything that we do is owned by Stanford. But Stanford is very forward-looking in licensing the code to potential startups like Google or Yahoo or whatever have been licensed in the past. So because another option for the project is if the students want to, after they finish their degree, start a company, I'm sure Stanford would license it to them as long as Stanford will continue using the code, but then the Stanford would get royalties or donations from the alums eventually. That's sort of the Stanford model for these things. Yes?
Okay, so my question would be comparing to the other open recommendation system like Delicious, Netflix, or even Amazon, right? Is the flex recs, that kind of algorithm generally applicable? Or in another word, being closed other than protecting user privacy, does it buy you anything else?
Well, the question is, does this buy you anything else over what Amazon or other sites are doing? And the key thing here is not that we're going to do different recommendations. I mean, this is a modeling framework, so we could represent very easily exactly the same recommendations that Amazon is doing or that Netflix is doing. So our contribution, we think, is a general framework for representing all types of recommendations with more flexibility so that we could then experiment more easily with other approaches.
Okay, a follow-up question is do you imagine that they actually use similar algorithms for recommendation? Yeah.
Well, good questions. Do the companies use similar algorithms? They're close and they're not going to tell us exactly what they're doing, so we can only guess. As far as we can tell by looking at the literature, they are doing that type of thing. I mean, I don't know, maybe somebody has some insights into what the companies are doing, but we think they're doing similar things, comparing against other people who have purchased things like you and so on. I mean, that seems to be what is being done. And this model definitely captures that type of connection and hopefully other types of new ways of recommending. Yes, June.
So with this representation of the recommendation workflows, will students be able to even search or query or even get recommendations for which recommendation workflows to use?
It's a good question. So the question is, can we get recommendations for which workflow to use? I hadn't thought of that, but why not? We could recommend workflows. Yes. Yeah. Yes, please.
So another question on the social effects of this. So there might be some unintended effects, right? It might be, for instance, that people start going into certain separate tracks and they get really, really nervous about going off their track, right? Because they see okay, well, everybody else who's taking these courses is also taking this course and nobody is taking this course, which sounds interesting, but guess what? The last person from my track to take that course, that was 4 years ago and he got a C, so I'm not going to do that, right? So you might, and I mean, this is something that applies to, I guess, all recommendation systems like Amazon as well.
That's right. That's right. Yes. So.
But it's just sort of.
At least we might be able to study these effects. Yes. Yes. So there can be unintended effects. I mean, some of my colleagues at Stanford tell me, "Oh, the students are just going to use this system to look for easy classes, so it's going to have a bad effect." And I have two answers for that type of comment. Well, yes. First, don't you think they already know which are the easy classes without CourseRank? So that's no big secret, at least at Stanford. I'm sure it's not a big secret here either. And two, yes, there is that potential disadvantage, but there's also a lot of upside, right? They can now discover new classes that they might not have thought of, that the recommending system might actually make some useful suggestions for them, and it might actually broaden the things that they might consider beyond what their roommate is going to tell them to do, right? So I think it's a balance, and if we trust our undergraduates and our graduate students like I do, I think they'll be able to take good advantage of this and not abuse it. Is there another question remotely? No, I guess not. How are we doing on time, June? I think we're past our time. Who's in charge?
One more question.
So FlexRex, I think you were making a generality argument, or it seems like you guys believe the whole ranking or the workflow and essentially those operators in there can be more general. They can express more general ranking or workflows for recommendation. So have you actually gone about trying to make such an argument, not only applying these things to rank courses, but maybe also movies?
Not yet. We've gone out and done other targets. So in addition to courses like recommend majors, right, or quarters. So we've been able to deal with, like, for recommending courses, you have to sort of look at the sequence in which courses are taken and so on. So we've been able within the framework to do that. As I said along, this is a new project. Yes, we should look at movies or other types of applications. Although intuitively, I don't really see why. I mean, I think the movies is simpler than what we have here because there are fewer constraints.
Like if you have sequence, if you want to take sequence into account, will that be captured in the nested relational sort of a model? Is that, and the operators?
You can, because, I mean, you just need comparison functions when you compare two tuples that consider the sequence of things.
Right, but